Alright guys, so for this video, I'll be talking about nomenclature. So nomenclature is essentially how we how we name molecules, okay? So given any molecule, we have a set procedure of how to go about naming it so that anyone can name it, and no matter where that person is or what organization or where they're from, that there is a universal way of naming molecules so that anyone can look at a name and they can get that molecule from the name and they can draw it out exactly the same way that the person who named it saw it. Okay, so that's essentially what nomenclature is. It's a set of rules that we're going to use to name molecules in a very consistent and concise way. All right. So for your first exam, it's the easiest nomenclature that you're ever gonna get. All right. So you're never, we're only dealing with just straight carbon chains. We're only dealing with the carbon chains and the substituents, no double bonds, nothing crazy. Okay. So no actual what we call functional groups. So the first rule that we want to look at for nomenclature is, right, we're always interested in finding the longest chain. Okay, we're always interested in finding the longest chain. Okay, and for the second rule, we're interested in finding the chain with the most substituents, right? And for the third rule, after that, rank direction based on lowest number substituents. Okay, so these are your three main rules that we're going to use to kind of figure out what we call the parent chain. So instead of just blabbering, the best way to go about this is to do an example. All right, so if I had a chain that looks like this, okay, right, and it will look this crazy, right? It's a really random molecule. It can look this crazy. So what I do first, for the first rule, my first thing that I want to do is I want to look at where do I have my longest chain, okay? And what's really helpful is to just recognize very quickly is to check if I have any planes of symmetry. So a plane of symmetry is where along, it doesn't have to be the entire molecule, maybe it's one part of the molecule. So for example, this part right here, this top part and this bottom part are exactly the same coming off of this carbon. So whether I start over here, whether I start over here, it's gonna end up going the same length, right? Whether I go up into this side or go down to the side. Just want to say that really quick. So the first part, you kind of just have to eyeball it. Where do I think I have the longest chain? From where do I think I have it? So I'm gonna use a different color. Let's see if I can. No, use a different color. Maybe. All right, use red. Right. So if I start over here, okay, that's not red. Whatever. If I start here, I think I'm gonna have the longest chain if I do this. So 1, 2, 3, 4, 5, 6, 7, and I said either I go up into this side or this side, doesn't matter. I'm still gonna get 8, 9, 8, 9. So 8, 9. All right. So that's essentially what we're doing. We're trying to find the longest chain. Right. I'm looking and I'm trying to eyeball where do I think I have the longest chain. Does it look like I have any like actual competitors with this one, a similar length chain? Not really. Okay. So once I've done the first rule, right, I'm confident that I've done the first rule. I've found the longest chain. That's the first and most important thing. Now I need to find the chain with the most substituents. Okay, so this rule is here actually just to kind of, it's like a competing rule. So in this case, I have an easy example, right? But sometimes you might have a chain where you have two different paths, two unique paths, right? And they are the exact same length, okay? And you'll see this through some examples that are designed to make you know these rules and use these rules. So if you had two chains and within a chain with two paths of a chain, and within those paths I had the same number of carbons, they're the same length. So let's say they're both 9 carbons long. And I have to choose now which one's going to be what we call the parent chain. Parent chain is just, let me write this out. All substituents off of, and what we use to give the name of. So like what this means is the parent chain is what we're gonna put all the substituents coming off of it. So substituents are the other groups that are not part of the longest chain. And this second part is what we use to give the name of the molecule. So whether we're going to say this molecule is 9 carbons long, 8 carbons long, 7 carbons long, that's going to be determined by the parent chain, right? We're not going to look at, oh, this whole thing is a total of like 15 carbons. We're looking at the longest chain, and that's going to be what we use, the number of those carbons that we use to like name the actual molecule itself. So for number 2, this is if I have two, paths within a molecule and they're the same length, and then how do I know which one's going to be the parent chain, right? They're both 9, for example. So the way that we figure out which one we're going to use for the parent is we look at which one has more substituents coming off of it. So the one that has the most substituents coming off of it, that's going to be what we use to name the chain itself. And you'll see this through example. And the third rule is rank the direction based on lowest number of substituents. So what the heck does this mean? Well, after you found your parent chain, everything's all good and done. We have two ways that we can number this, right? So yes, I numbered it 1, 2, 3, 4, 5, 6, 7, 8, 9, but I can also number it from this direction 1, 2, 3, 4. This is 5, right? 6, 7, 8, 9. And these numbers are very important, right? These numbers are going to tell us where the substituents are coming off of. Like this group is coming off of 3, or it could be coming off of 7. It depends on which direction I'm going. So I have to choose that direction, and the way that we choose that direction is where the substituents are placed. So I haven't figured out how to change the color yet, but if you can bear with me, right? So if I'm going in this direction, right? So I'm going in the left. So I'm gonna call this. I'll put an arrow going left, and I'll put the numbers on it. So going in the left direction, right? Counting this way, I have a substituent coming off. This is a substituent right here, coming off of 6. Coming off of 4. Right? This is 4. So 4, and then I have one coming off of 5. This group right here, and coming off of 7, I have this group right here. So 4, 5, 7. I have 3 substituents that are not part of the parent chain. If I go in the opposite direction, so if I go in the right way, if I go right, I have a group coming off of 3. I have a group coming off of 5 still, and I have a group coming off of 6. Okay, so 3, 5, 6. So what I do now, I have labeled the number where the groups are on both molecules, the directions. So what I do now is I just quickly see which one reaches the substituents first, right? So this one, the first substituent appears at 3. This one, the first substituent appears at 4. So this direction is going to be our winning direction. This is the direction that I'm going to use to name the molecule. This is the direction I'm going to use to name the substituents. Okay. This is a 6, not a B. Right. All right. So I have found the direction that I'm going to use to name the molecule. Now all that's left is the actual naming, right? So before I go into that, let's just write down some of the names of the molecules. So just gonna pause real quick. All right, so here are the names of the molecules. Okay, so we have methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, and this is going from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Besides the first four, 5, 6, 7, 8, 9, 10 are all pretty easy to remember, right? They go with the name. So pent, go 5, hex 6, hept, oct, we're all familiar with that. The first four can be kind of hard to remember. So the way I always remember this is M, E, P, B. I always remember me, eat, the P, peanut, butter. Me eat peanut butter. And it's dumb, but I've always remembered it, and I always now do it whenever I'm, trying to remember the name of either methane, ethane, propane, butane. And I remember it in this order because this order helps you, me eat peanut butter, 1, 2, 3, 4. So butter is the fourth word, 4 carbons long, blah, blah, blah. So that's just a little moniker, whatever thing to help you remember the first four. The next ones are pretty easy. So here I have a 9 carbon chain long, and so that means my parent is going to be a nonane, right? My parent is nonane. So this is nonane, right? So these are ends. My parent is nonane, so now I have to take care of the rest of the naming, right? So when we do this, we have to first thing we want to do, we found the direction, so that's really important. It's important because it tells us the numbering of where the substituents are, right? I could have 2 different numbers where the substituents could be. So here I have now I'm going to do the numbering for each one. So the way we number substituents, we put the number and then you put a dash, okay? So here I have on number 3, I have 1. So you always count. This is the carbon on the parent chain. So I count off of the parent chain carbon. So from the parent chain carbon, I have 1 carbon, 2 carbons. Okay, 1 carbon, 2 carbons. So this is going to be ethane, right? This is an ethane group. But whenever you have it as a substituent, these are for the parent. The E is for parent. But when I make it into a substituent, you drop the E and you add YL. So this would be 2 carbons long, so it would be ethanil, right? So 3 ethanil, okay? Ethanil, right? So that's on 3, and then on 5, I have 1 carbon, right? So coming off this right here is 1 carbon. So, not ethanol, right? You drop the ane, right? And then you add YL. My bad, guys. So not 3 ethanil, it would be 3. I knew something was off about that. 3 ethyl, okay? 3 ethyl, okay? It rolls off the tongue a lot more nicely. And on 5, we have 1 carbon, so this is going to be methyl. It's pretty easy, okay? And then off of 6, I have another 1 carbon long, so I have 6 methyl, okay? So I want to look at these 2 methyl groups, right? So whenever you have 2 of the same kind of substituent, right? I have 2 of the same, 2 methyls, there's at different numbers. So the way that you write this on the actual name, put 5, 6 di, right? Methyl. So you always have to put a abbreviate. You have to add the number of methyl groups. So if I had 3, I would say tri. If I had 2, I say di. If I have 1, you just say methyl. Okay? You don't have to say monomethyl. So these are the substituent names that we're going to use in the chain. Okay. All right. There is actually a fourth rule, but it's very rare for it to occur. But I'll just type it out. So the fourth rule is if you have so if you've done all the first three rules, right, and you still have like a competing chain that has the same length, has the same number of substituents, right, and you can't yeah, it has the same number of substituents, and on the direction, the numbering, they're all the same. So let's say, like, for example, if I did the first two, and then when I came to the direction part, I had both 3, 5, 6, and the other one was also 3, 5, 6. Okay, so if all those you still haven't found the direction of the molecule, or the parent chain, you're going to if all above have been satisfied and parent not found, what you're going to do is you will based off of alphabetical order, the direction will be found. Okay, so you found your longest chain, and you found, the one with the most substituents, let's say, but the numbering from left to right is the same. So what we're going to do to if I can move this somewhere where it's visible. What you're going to do is you're going to use alphabetical ordering to figure out which direction is best. So if, let's say, from left to right, I had the more alphabetical arrangement of the substituents. So let's say I had, the very first one was something that started with E, and the next thing started with something with B or whatever. So I had ethyl butyl. But on the other way, I had, let's say, methyl and then ethyl or whatever. So you're just going to look at, do I have the most alphabetically ordered, which one has the most alphabetically ordered substituents? And that's going to give you your parent, okay? All right, so I'm just going to type it over here. So 4. All right, so this is rule 4 right here. Okay, based off okay, I already said that. Okay. All right, so that may not make sense right now, but we'll see these rules applied through examples. So this is everything you need to know for nomenclature, essentially. Okay, a long explanation, but let's jump into some examples. All right. So I'm gonna go from the workbook stuff, and I'm just gonna give you guys some examples from there. Okay, so I have this. This is number 1. Actually, I'm just gonna copy and paste this. This is worksheet 6. All right, let's just do the first couple ones. All right, so here I have this group, right? I have this group right here, and I need to name it. So if I just eyeball this, I'm pretty sure I can find that this is the longest chain right here. So I'm gonna start naming it 1, 2, 3, 4, 5, 6. Okay, so I have a 6 carbon long chain. This is a hexane. Now I'm going to number the other direction. Okay. Let's see. All right, so I figured out how to change the color. So if I number it this direction, so the red color. Ooh. Okay. So this is 2, 3. This is 4. Oops. Okay. 3, 4, 5, 6. Okay. So now I need to do the numberings. So from going from the red direction, so from left to right, so I'm going this arrow, and then I have this arrow. Okay, so I'm just going to use black from now. So the black direction, I have a substituent. These are my substituents. I have only one substituent. So the substituent is on 3. Okay, but for the red direction, my substituent is on 4. So I'm going to go with the black direction as my path. Okay, so I hope that makes sense for everybody. Okay, so all I have is for this molecule, my name is just going to be, right? It's a 1 carbon long, so it's going to be a 3-methyl, okay, hexane, right? So now you just name the whole thing. So 3-methyl hexane. So once you've given the last substituent, so here I only have one substituent, so this is the last one, it's going to be named 3-methyl hexane. So you just merge it with the parent, okay? So that's all for that one. Now for the next one, let's number it. So if I eyeball it, it's pretty much the same thing as the last one, okay? So 1, 2, 3, 4, 5, 6, 7, okay? And if I go in the red direction, it's going to be 1, 2, 3, 2, 3, 4, 5, 6, 7. All right. So now I'm going to circle my substituents, and I'm going to do the directions. Okay. So I have a substituent right here, and I have a substituent right here. They're both methyls. So when I go from left to right, so this is the black direction, and when I go from from left to right, this is from right to left, and then the red direction. Okay. The red direction, I have substituent on 3, and I have substituent on 4. And then when I go in the black direction, I have substituent on 4, and I have a substituent on 5. So the red direction is the winner in this case. Okay. So I want to go in the red direction. Now, when I name this, I have a, let's see, I have a 3, 4. I have 2 methyls, so I'm putting it dimethyl. So these are my substituents at the moment. Okay, I have 3, 4 dimethyl, and my parent chain is 7 carbons long, so that's a heptane, right? So I have a heptane. Okay, heptane. So my parent chain is going to be called 3, 4 dimethyl heptane. So easy, right? It's really easy right now. Okay. Now let's do number 3. It looks a little bit more complicated. I'm trying to speed things up because I'm already at 23 minutes. So let's just eyeball this one. This is a little bit more complicated, right? So if I eyeball it, it's okay if it takes me a few tries, right? First thing, I want to be careful of with these more complicated ones. I want to see if I have any symmetry. So when I look here, I don't see any symmetry over here, but I see some symmetry over here. If I go off this carbon right here, this going up over here is symmetric, going over here is symmetric. So whether I number it up in here or whether I number it down here, it's the same, okay? And then over here, I have this group. So if I eyeball it, I'm pretty sure that my parent chain is going to be along this, right? Over here or over here. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And if I go in the red direction, right, I'm going to have, right, this is going to be 1, this is going to be 2, this is going to be 3, this is 4, 5, 6. Oh, did I miss something? 1, 2, 3, 4, 5, 6, 7, okay, 8, 9. All right, so that's what I have. And I just want to check real quick if I have done anything wrong. So I'm just going to do the red arrow like this, and black arrow is going this way. Okay, so just make sure really quick if I have any, if I have a longer chain. So I'm pretty sure this is the longest one, but let's check. If I count 1, 2, 3, 4, 5, 6, 7, 8. So going into this one is only 8. Going over here, it's 9. Right? And this one I'm not going to compete. Okay. So going in the red direction, let's find my substituent. So this is one substituent over here. So this 2 carbon long one. This is a substituent, and this is a substituent. Okay, so I have 3 substituents. If I go in the red direction, I have 1 on 3. Then I keep going, I have 1 on 4, and then I have 1 on 6. If I go in the black direction, I have 1 on 4. I have 1 on, right? This is 6, and then 7. Wow, very easy. So this is the winning direction. The red numbering is the winning direction. So now let's label what we have on these numbers. So on this is the red direction. So on 3 I have 2 carbons, right? This is a 1 carbon. So you can start counting directly off of the parent chain. So the first carbon off the parent chain is right here. So this 1, this is 2. So that's an ethane group, and as a substituent we call it ethyl. So I have a 3-ethyl, right? And then I have another exact same, I have an ethyl on 4. So I have over here, I have a 3, please type 3, 4, so I have 2 of them, diethyl. It's really easy to forget the di, and you will get points off for it if you forget it, all right? And then on 6, I have 1 carbon, right? This is a CH3 group, so I have 6 methyl, right? So pretty easy. Okay. Now our parent, now I name our parent is 9 carbons long, so that's going to be a nonane, right? Our parent is a nonane. So one thing I forgot to mention is that once we have our substituents, right? We have 2 different types of substituents here now. This is a different type of example. So how do I know what to put first? Do I put the 3,4-diethyl first, or do I put the 6-methyl? Because it's not based off of what numbers came first. It's actually based off of the alphabetical order. So when you name the chain, when you name the whole chain, it's going to be based off of alphabetical ordering. So when you have multiple substituents of different names, you order them alphabetically. So what comes first? And you don't include the di. The di is not included. So do I include the ethyl part? Right? It's the E versus the M. So alphabetically, E comes first. So I have 3,4 diethyl, and then you put another dash, right? So you put a dash every time you finish a substituent. Then I have 6-methyl, right? And then this is my last substituent, so I don't have to put another dash, and I can just name the parent. So nonane, right? So that's our parent group. 3,4-diethyl, 6-methyl nonane, right? It's not that bad. So I'm just going to put up here the last rule for now is order substituents on parent chain alphabetically. Okay, so that's the next rule for now. Okay, so let's choose some hard problems. Okay, yes, I have a hard one for you guys. So I'm going to jump to problem number 9. I'm gonna look at these, okay? Problem number 9, 10, 11. Right, the page. Problems 9, 10, 11. Okay, so now just looking at this, what do? I need to just eyeball it, and I just try and see where I think my longest chain is. So it's either going to go up and down here. This is symmetric, right? So this is symmetric over here, and it's symmetric along here. So whether I start from this side, it's all the same. So I think my longest chain is going to be if I go from one end to the other. 5, 6, 7, right? I can just see if this will be longer. So if I go here 4, 5, 6. So it's definitely longest going like this. Okay? If I do the red direction, it's just 1, 2, 3, 3, 4, 5, 7. All right. So red direction is going in this way, right? Black direction is going this way. All right. So red direction. Now let's find our substituents. I have a substituent right here, and that's my only substituent. Okay. So that's my substituent for now. I'm gonna go into some extra naming at the end because it's it's not necessary. Okay, actually I can do it right now, but it's not necessary. There's two ways to do this. Okay, so I have one substituent and they're both on 4, so it actually doesn't matter which direction I go. So if you see this 4, 4, they're both 4. So it doesn't matter whatsoever. No matter what you do, it's not going to change anything. All right. So I have a 4, and now what the heck is this? So 4, I have 1 carbon, and now I have 2 different ways. How do I do this? So what you do is you find the longest chain in the substituent. Okay? So here it's even, so it doesn't matter whether I go like this. And then substituent is going to have its own substituent. So the substituent of 2 carbons long has its own substituent of 1 carbon group, right? So the way that we name this is, right, so it's going to be, okay, let's do it down here. So it's 4, right? And I said this is a 2 carbon long, so it's going to be 4. And what we do before I start typing, right? So whenever you have a substituent within a substituent, right? I have a methyl group coming off of an ethyl group on the parent chain. So you put a parentheses, and then this methyl group is coming off of the first carbon of the substituent. So I have 4, 1 methyl, and I call it ethyl. So it's 4, 1 methyl ethyl, right? So that's how I would name this as a substituent. Okay, it's kind of crazy, but just I want to give you guys an example of a substituent on a substituent. Nothing really that different. Another way to name this would be to call it what we call isopropyl. All right, this can also be called isopropyl. Right, and I want to go in real quick and talk about these iso and all these different ways of naming this. So there are certain types of substituents that we can use a name to describe them. So isopropyl is going to be a substituent that looks like this group over here. It's 3 carbons and it looks like this. All right. So when I name this, I can name it 4, 1 ethyl, right? Heptane. Okay. Or I can name it, right, 4 isopropyl heptane. Okay, so there are 2 ways to name this molecule, right? So either this or this, both are correct. Just I honestly I prefer the top one because sometimes you won't be able to have this this name here work, right? You don't have a name for every single type of substituent. So I like to get comfortable with doing the really crazy substituent on a substituent naming. So I prefer the top one, but if you like the second one, that's your choice. Okay, so real quick, I want to go to Bean's notes and I want to look at something here. Okay, and I'm just gonna look at all the groups. Okay, all the different types of substituent groups. I'm going to refresh the page real quick, and I'm gonna put this up here. So these are the types of groups over here, right? And what we just did, we did the isopropyl, okay? and she's shown us that we have methyl, propyl, butyl, pentyl. So this is when you have one carbon substituent. This is a 3-carbon substituent, right? This is a 4-carbon substituent. This is a 5-carbon substituent. Okay. So these are groups that are coming off the chain. The squiggly line indicates I have a main chain, and this is a substituent coming off it. So that's what this represents. The squiggly line represents a parent chain, and this is a substituent. Okay. So you have to know these, right? Whether you like to name it with these names or not, you have to know these because based on how the test works, she can give you a name and she'll ask you to draw the molecule, but most of the problems she gives you a molecule and she asks you to name it. Okay? So the way I memorize these is I get familiar with what ISO looks like, what TERT looks like, and what NEO looks like. So the only ones you have to actually memorize are NEO and the SEC. All right, ISO and TERT, they have a repeated way of looking, and I'll show you what I mean. So what ISO looks like, right? ISO looks like when you're coming off of the parent chain, so squiggly line. ISO is always like this. It's always the final the final carbon, right? I'll call it the final carbon, and you'll see why I call it that. And then you have two methyl groups coming off, so a CH3 and a CH3. Okay. The other iso group is right here. So I have isopentyl. It's 5 carbons, right? And so what you do is the whole iso group, it consists of 3 carbons. So that means I have 1, 2, and then, right, I have 2, and then off of the third one, that's when I have the iso group. So the third one right here is the final carbon, and that's when I have the carbons coming off. So iso is always at the very end. So as long as you keep in mind the number of carbons that you're working with, right? So whether it's 3 or 5, iso is always just putting this little group at the very end of the substituent. So I said I have 5. I know this is 3 carbons in total for the iso, and I went 1, 2, 3, right? 1, 2, and then on the third one, that's when I added it. So I drew 2 out, I drew 2 carbons out, and then I put the iso. Right? I hope that's not confusing anyone. That's how I, to get out of having to memorize every single one and whatever. I just knew what iso looked like and how it worked. Now for TERT is coming off of the first carbon that comes off the substituent group. So as you can see, the parent chain is right here. This is the first carbon of the substituent, and then I have 2 CH3 groups coming off of it, and then the rest of whatever is left of the substituent. So if it's a TERT butyl, this whole thing consists of 4 carbons. So the TERT butyl is all is 4 carbons itself. So the whole TERT group is 4. Now if I have a TERT pentyl, right? I said that you have, this is the parent, right? And then the substituent comes off. I have the first carbon. So the first carbon has the methyl groups. I don't want to draw it like this. The first carbon has the methyl groups, okay? So 1 going up, 1 going down. So I've already used up 1, 2, 3, 4, and now I just draw the 5th one. And that's how I know what TERT butyl looks like. Just off of the first carbon, you have these 2 CH3 groups. And for iso, at the very last carbon of the substituent, you have 2 CH3 groups. All right? Sec and neo, you have to memorize them. Okay? There's no way of getting out of it. So that's how you need to memorize these names. It's very important. So go back to her notes or open up the website and memorize these. Okay? So back to naming. Alright. So we did 9. I'm going to do, let's do 11 and 12 now, actually. Alright. So almost done with this video. So now I have these 2 stupid groups. I'll show you how to name it both ways. And let's just eyeball and see where the longest chain is. Okay? So what I think is it's either going to be like this, going up into here, or it's either going to be going over here. Alright? So let's just see. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 if I just go like straight up all the way across. If I go into this, I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 if I go into the substituent. So my parent is going to be all along here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And now the red direction, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? The red direction is going in this way, and the black direction is going in this way. All right, the black direction, these are my substituents right here. So this one and this one, right? And I just discussed what those are, right? So on 4, I have 1 on 4 going in the black direction, and then 1 on 6. Okay, and in the red direction, I have it on 4, and I have it on 6. Okay, so it's the same way, both directions, but they aren't the same group. So even though they're the same number, I can still choose a direction for this to go. So alphabetically, right? Alphabetically, right? Isopropyl and isobutyl, which is what I just gave it away. Isopropyl and isobutyl, this is what we have here. Those are the only ones that count alphabetically. So the I in isopropyl and the I in isobutyl are what counts alphabetically. So the I counts, and then here we have 2 iso groups. So I have to go down the name, and I have isopropyl, isobutyl. So isobutyl is the winning one alphabetically. So this is the isobutyl group, right? It's not isobutyl. That's tert-butyl. My bad, right? So this is the tert-butyl group, right? So I'm comparing the B in tert-butyl. This is another way of just saying tert. My bad. Comparing the B in tert-butyl to the I in isopropyl. So B comes before I, obviously, so the B direction, the tert-butyl direction wins, right? So that's the red direction. Okay, so here I have, let's see. All right, so here I have 4, right? 4 tert, or you can also put it like this, tert-butyl. You can also spell the tert, it's just one way of doing it. And then I have 6 isopropyl. Okay. All right. Forgot to make the other one smaller. All right. Now let's name it the other way. Let's not name it using this way. Right. So if I wanted to name it the other way, right? This is my substituent. Right. These are my substituents right here. So if I name them normally, the first carbon going in, I find the longest chain. So it's always going to be 2 carbons whether I go into this way or this way. And then off of carbon 1, for this one, I have 2 methyl groups. Right? So the way I would name this one, right, is going to be, right, so it's going to be 4, right, dash, right, because it's 4, that's where the whole thing is coming off of. Then I'm going to put a parentheses, right, 1, 1, dimethyl, ethyl, all right? So that's what we call that one, all right? And if for this one, I have the same thing as I did before. So I have a methyl group coming off of the first carbon right here. So this is going to be, right? So this is on 6, right? Okay. So it's 6, right? So 6, let's see, 1 ethyl, right? Awesome. All right, so now I have two things, okay? So now these are my 2 ways of naming it. Now I can make the parent chain, okay? So, like I said, when we're making the parent chain, we have to order these things alphabetically. So I already said that butyl comes before isopropyl. So because the B is what counts alphabetically and the I is what counts alphabetically for iso. So I start off 4-T-butyl, right? 6-isopropyl, and I have a 9-carbon chain. So that's the first name, right? Now if I do the other name, okay, so I have 4,1,1-dimethyl, and then I have 6-methyl, right? So these are very difficult to compare because I have the same numbering on them. I mean, the di doesn't count, so I have M, and I have ethyl and ethyl. Okay, so what I would do for this one, let me see really quick. Right. Okay, so this one's kind of a tricky one because they gave you 2 of those groups. But what I would do is I would try to, I think if I was trying to do completely with just the numbering, numbering the chain method, I would try to just do it in order. So whichever one came first. So I would do 1,1-dimethyl ethyl, dimethyl ethyl, I think I'm spelling that right. And then 6,1-methyl ethyl. Usually it won't be, you won't have 2 of these like they have substituents on their substituents. So you won't have a complicated case like this usually. But if it's confusing to know which one to do, I could do a combination of the 2. So I can do 4-T-butyl first, and then I can use this name if I feel like it, right? So I could have put 4-T-butyl first, and then I could say 6,1-methyl ethyl if I felt like it, no name. So that way it would be very clear which one comes first, okay? So there's that one. Now let's quickly do number 12 and let's finish this video. It's already getting pretty long. So let's see. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 going all the way through here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I found my longest chain. So I'm going to start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, now in the red direction. All right, so 1, 2, 3, 4, 5, 7, 8, 9. All right, so going in the red direction and then going in the black direction. All right, so the red direction, where's my groups? My group, I have 1 right here. I have this whole crazy thing right here. And I have this group right here, right? So I have 2 methyls and I have this crazy thing. So I have 3, right? 3, 5, and then 8, okay? And then in the black direction, we're going to see really quickly, we have 2, right? 2, and then this is also 5, right? 2, 2, 5, and then 7, right? So I have 2, 5, 7 versus 3, 5, 8. This is the winning direction. I'm going to use the black direction, okay? So now let's start naming these constituents. I'm going to start with the methyls first. So I have 2 and 7. So I have 2,7-dimethyl, right? Okay. And now let's name the other thing. Let me switch to this. So starting off from the first carbon, coming off of the parent chain, I have 1, 2. This is symmetric, so I can just go 3. All right. So I have 1, 2, 3, and then I have methyl groups coming off of the 1 and 2. So this name of this substituent is going to be, right, 5 dash parentheses, right? And then I have 1, 2, 1 comma 2 dimethyl, and this is 3 carbons long, propyl. All right? So that's the name for that one. Now I can start. Now I can name the whole thing, right? So for the whole thing, right? So let's see. E, F, G, N. Okay. So the way you do naming, right? So I have to alphabetically organize the dimethyl and the dimethyl propyl. So we don't count the di, we're just looking at the M, right? So they're the same so far. And then up and then I have the propyl. So the way that this works, alphabetically, dimethyl is going to come first, right? Without the propyl group on it. So the way that it works is kind of like a dictionary, right? You're first going to see the word, like let's say you had the word car, right? You would see that first in the dictionary. And then after that, you would see later on carnivore. So this comes after it, and so I'm going to choose a thing that would come first if I was to organize it. I hope that makes sense, that kind of analogy. Okay, so when I do my parent 2,7-dimethyl, all right, why did it become weird? All right, 2,7-dimethyl, and then 5-1,2-dimethyl propyl, right? Okay, and then how many carbons we said we had? We had 9, so no name. So that's our full name for this chain. Okay. All right, so that's the gist of nomenclature for now. There's gonna be some additional stuff after the next video that I have to add in, but it's not too bad either. All right, see you next video.